This is a little helicopter that we just got access to that is able to come in and take remote images of a study that we have where we're trying to look at or trying to develop an economic threshold for irrigation of wheat that is diseased with wheat streak and other mite vectored virus diseases. The project or the problem with farmers is that these diseases develop in gradients over time, and they don't know whether or not they should apply new pesticides or fertilizers or water, and most of this is done in April, and this is when the disease is just starting to show up. So they may know that they have disease in the field, but they really don't know whether or not what it's going to do. And so what we're trying to do is to be able to go in early in the season, look at the disease development at a particular time, and then based on what it looks like, say early April, be able to give them a prediction of what the crop will be at harvest time. And so to do that, we've been going in and using different types of remote imaging to measure and quantify the severity of disease development in the field. And now with the application and use of this helicopter, it's just one more way of going in and measuring the disease development. The beautiful thing about this, instead of having to do it with hand, you can come in and fly the entire field in a matter of 5 minutes, and it has a very, very high resolution. And so we're very, very excited about the possibilities that this may provide for our project.
And basically this has an autopilot in it that allows us to pre-program flights and have it fly a grid. And so as it's flying its grid, it's collecting top-down photos. Once we collect the photos, we then stitch them together and build a giant photo mosaic of each field that we flew over. So we're hoping to provide incremental photo coverage of the fields as the disease progresses through the fields. It's a pretty simple system to fly once you learn to program it. Basically, we just turn it on and we just let it fly itself. Many researchers have used satellite imagery before, but this provides resolution 100 to 1,000 times greater than satellite imagery. So that is a huge improvement when you're looking at ground coverage and trying to pick out diseased plants. Another improvement is temporal resolution. We can fly this every day for a couple of weeks. We can fly it every week for a whole season. Whereas with satellites, you'd have to wait 2 to 3 weeks for a pass if you can get your slot. So that's a great improvement as well. Another thing is we're currently using this with visual spectrum only, so just still photographs. This project is focused on the yellow band, but this is a modular system. We could put near infrared, we could put thermal, we could put any array of multispectral sensors on here to capture whatever data it is that the project demands.
One of the things that we're really excited about with this new technology is that although aerial images have been taken before and unmanned aircraft have been used to measure things, they've never been used, to our knowledge, to manage irrigation applications, especially in diseased crops. And so this is something that's totally new, and obviously in the Texas Panhandle, where water is such a precious resource, anything that we can do to reduce waste or wasteful applications, or farmers putting it on when it's not going to benefit them or not end up paying off for them, is going to be a positive thing. And we have great confidence that with the studies that we are currently doing and the application of this new technology, that we are going to be able to very quickly provide growers with the information that they need to better manage their irrigation.